Welcome to Brain Vision.
This question reads, the disk in figure 10.29. So I'm going to look at figure 10.29. That was question 65. So it was a figure that looked like this. It was a disk with a hole cut out of it. And we knew the radius was R. And then we knew that the radius of the hole was 1/4 R. Okay, so that's what we had for question 65. Let's continue with this question here. By the way, in question 65, we figured out that I was 0.494 mR squared. Now, since the disk is unbalanced, its angular speed varies as it rotates. So let me think about that. This disk is definitely unbalanced. And so since it's unbalanced, especially if it's rotating around a horizontal axis, then yes, it would change its speed. I'm wondering if back in question 65, it told us that this was rotating around a horizontal axis. Because if it's going around a vertical axis, then it's not affected by gravity. Okay, well, let's go back to page 184, 86 maybe. It doesn't say anything about whether it's rotating vertically or in what direction. Nevertheless, let's continue. If the maximum acceleration speed is omega max, find an expression for the minimum speed. Well, I guess I'll call that omega min. So, it's spinning around its center So we know that torque equals I alpha. We're talking about omega here. Well, our hint is, how does the potential energy change as the wheel rotates? I'm thinking that I really wish I would have saved all my work for calculating the inertia. However, I think we can do potential energy. Potential energy, whoops. Here we go. Trying to get something to write with here. Potential energy is mgh. So, we've got two objects here, kind of. We've got the main disk, and then we've got a small, tiny disk cut out of it. So I'm going to say the potential energy of the main disk is its mass, which would be, I think I need to go back to the question. I guess the mass is just m, capital M. G is just G. But h, I'm going to redraw this like this being the center. So h is going to be 0 in this case. Oh, wait a minute. If I want to set there, this is going to be 0. So I could make that 0. So nothing. Potential energy of that missing element. What do you call that? What did I call the first one? I don't know, but I'm going to call it whole. Is mgh, but its h to its center of mass is 1/4 of the radius. So that's going to be mg 1/4. Why I wrote r when I said g, I don't know. 1/4 mgr. Okay, so the change in potential energy in one direction, it's going to be positive 1/4 mgr, and in the other direction, it's going to be negative 1/4 mgr. So it's going to be twice as much. So it'll be 2 times 1/4 mgr, which would be 1/2 mgr. Okay, so that the change in potential energy, whether the hole is upward or downward, is 1/2 mgr. Interesting. So now let's write about conservation of energy. And I don't know if I have enough room here, but let me give it a try. Potential energy initial plus kinetic energy initial, or at least in one state, is going to be kinetic energy final plus potential energy final. Okay, so if we put the two together, I'm just going to write delta U, initial minus final maybe, is the opposite of delta K. And we know that delta U is 1/2 mgr. Delta K would be kinetic energy is 1/2 I, which we know, omega squared. So this would be omega min squared minus, and I'm running out of room, omega max squared. Okay, so 1/2 I omega squared, 1/2 I omega squared. So the halves are going to cancel out. The question again is, find an expression for the minimum speed. So, well, I'm going to divide by I by negative I actually on both sides. So that's going to give me and I'm going to go to another page here. Omega min squared minus omega max squared. And let's see what else we had here. All I'm doing is dividing by negative I on both sides. So that would be negative mgr over I. So omega max squared minus omega min squared would be mgr over I. All I did was multiply by negative 1 on both sides. So find an expression for min. Well, I shouldn't have done that because I'm trying to figure out min. So let's go back. All I have to do is add omega max squared on both sides. So omega min squared is omega max squared minus mgr over I. And then I just take the square root of both sides. Okay, so I'm thinking as I came to an answer, does that seem reasonable? And I believe it does. So I should check and make sure I didn't make any computational mistakes. So basically, we're looking at the difference in potential energy of the whole, which is just mgr, mgh, I mean. So that's mg times 1/4 r, but it's going to go from negative 1/4 r. The center is going to go from the height of negative 1/4 r to positive 1/4 r. So that's a difference of half. So 1/2 mgr. Good. So then I wrote that 1/2 mgr is going to be negative I omega min squared, 1/2 I omega squared, change in I omega squared. That looks good. So I believe that this is good. So thank you for watching.